Good morning or good afternoon, everyone. This is Dan Hawkins with ThingTech. Thank you so much for taking the time to join us for today's webinar. We're going to get started here in just a moment. Before we do, I just want to go through a couple of quick housekeeping items. First and foremost, all your lines are muted today. We do encourage you to interact during the session. We do want this to be interactive. So certainly, if you do have questions, feel free to ask those in the chat. We'll be monitoring that throughout today's session and addressing every question that comes up either today on today's call, if we have enough time, or we'll certainly follow up with you on an individual one-on-one basis. In addition, I know that y'all are very excited about our giveaway today. We're going to be giving away a $100 Amazon gift card to one lucky attendee to today's webinar. The only qualifier for that is that you must be logged in at the end of today's meeting. So certainly stick around through the bulk of today's presentation. We're not going to announce the winner on the webinar today, but we will be notifying everyone tomorrow about the winner of today's gift card giveaway. So again, thank you so much for joining us today. My name is Dan Hawkins. I'm Director of Sales and Marketing here at ThingTech. Today's topic that we're going to be covering is the shift from reactive to proactive, what we like to call smart maintenance, by leveraging the IoT. During today's webinar, we're going to be really discussing how organizations are leveraging real-time connected IoT technologies to achieve digital transformation and improve efficiencies that can really have profound impact both on the top and bottom line of your business at the end of the day. We're lucky to be joined today by our presenter, Tim Quinn, the CEO and co-founder of ThingTech. Tim is an absolutely phenomenal resource, not only an industry veteran with over 25 years of experience in real-time technologies, having deployed hundreds of successful IoT projects across the U.S. and abroad. But Tim is an absolute wealth of knowledge when it comes to asset management, maintenance, and real-time IoT technologies. So thanks so much, Tim, for taking the time to join us today. Just to give you a little bit of background about ThingTech before we do get started, ThingTech was originally founded to specifically address the needs of asset-intensive organizations. So those organizations that own, operate, manage, and maintain valuable equipment, machinery, vehicles, infrastructure, and more. Using the convergence of enterprise asset management, real-time IoT data, and field service mobility, we've developed a really powerful and easy-to-use platform that helps you with the challenges that you deal with on a day-to-day basis. That's taking better control of your maintenance and operations, unlocking additional operational efficiencies, and measuring your success with deep analytics through our platform as well. So again, today we're going to be really talking about the shift from organizations really sitting in that reactive state to maintenance problems and moving into more of what we call a smart maintenance environment, more proactive, leveraging real-time connected data to make better decisions and ultimately streamline and automate a lot of processes internally. So with that being said, I want to turn things over to Tim, who's going to be running through a bulk of the presentation today. Tim, go ahead.
Very good. Thank you, Dan, and thanks everyone for attending. Just get started. We'll kind of discuss the agenda that we'd like to go through over the next 45 to. Obviously, we just do quick introductions, kind of give an overview of who and what we are, as Dan did. But I really want to focus on how do we get started with IoT and automating some of your maintenance operations, whether that's digital transformation or digital operational transformation, in terms of from reactive processes and reactive insight to very proactive, predictive, and a bit smarter to repair operations as it relates to your asset management, maintenance, and kind of what we call steady good repair programs in terms of inspections. So what I like to kind of give a quick overview of kind of some of the IoT technologies and communication things are out there to get a baseline of understanding of how the IoT, or more specifically how the industrial IoT can improve overall enterprise asset management, maintenance, and repair operations. We also talk, we'll do a quick kind of overview of what we think, or what the industry also thinks are the critical components for smart maintenance. And then I would like to do a hands-on demonstration. I like to be very practical in these types of webinars and make it real and tangible for you got to kind of get an understanding of how this can be implemented and how to get started really quickly. Then we'll quickly wrap up. As Dan mentioned, just it is our mission to really lead the industrial IoT for real-time analytics, operations, and data aggregation for organizations that own and operate a lot of expensive things, quote-unquote things. They also have a mobile workforce that maintain, manage, inspect, or operate the equipment that are vehicles that are out in the world. So when we try to focus on the things that we try to help our customers with, it's really four basic things. Where are my things? What condition are they in? How are they performing? And how can they be utilized to create a greater efficiency? Really, at the end of the day, four very basic questions that our customers need visibility into. They want to have processes for accountability. They want to measure their data. And they want to understand the performance of their assets and their mobile workforce, all in real time. And when we capture data and start connecting data in real time through the IoT, it really allows us to drive extremely tangible and real operational benefits. These types of systems are almost generated on day one. Whether you're monitoring your assets in real time, and when I say monitoring, not just location, it's also diagnostic data coming from that asset, whether it's a vehicle, power generator, a piece of construction equipment. And how do we reduce the maintenance costs by increasing uptime, minimizing any downtime for your assets, and then streamlining those work processes to the field, from the office or from the shop, from the garage to the field, and ultimately maximize asset productivity and extend the useful life cycle of your assets and equipment and machines. And at the end of the day, we really want to make your things smart. And we'll talk a little about edge computing or edge processing, of having very connected, distributed, and autonomous assets out in the world that can continue to learn even if they're disconnected from, say, the internet or from a server, which is a very strong trend right now. And if we talk about why now, and I just want to go through this very quickly, but there's a big focus for digital transformation, and we're seeing out in the industry and in the marketplace, it's evolving at a very, very fast rate, and it's beginning to disrupt the industrial landscape, the industrial environment. And when we look at where we're at now, what's being described as Industry 4.0, which is the IoT, where everything is connected and everything's learning and provided to help make decisions in real time. So we're seeing, from a growth perspective, we're seeing more increased vertical applications, which we provide very deep vertical applications for maintenance operations and enterprise asset management connected to the IoT with field service. We're seeing new marketplaces being developed. Big data and analytics is driving this push, and we'll spend some time on this, as well as machine learning and edge computing. So our platform, ThingX Connect, we've integrated this platform into some specific vertical applications that we'll be demonstrating on a hands-on perspective. But let's look at the current IoT landscape, and it looks kind of confusing, but this landscape in terms of what communication methods are available often creates a challenge for some of our customers to how to get started. And what we want to kind of discuss in terms of our approach, and we think is the best practice approach, is that, I just realized that my screen was not displaying. I do apologize. So let me just go through the slides we discussed, and just so you can get a visual of it. Operational questions, tangible operational benefits that we discussed, the fourth industrial revolution, which we are here now on this platform, and this industry 4.0 is driving digital operational transformation, specifically in the enterprise asset management, maintenance, repair operations, and field service industries. When we look at the current IoT landscape, I mean, we look at the communication methods to the left, the most basic, and really to the most advanced and wide area being cellular and ultimately satellite. Also, this is a scale for cost in terms of communication costs, as well as the types of devices and how that data is communicated back to our solution. You can get an idea. There's a lot of methods for communication. There's a lot of devices, a lot of sensors, a lot of machines out in the world that you can connect to, and how you mix and match your communication methods to the proper device or proper sensors or proper machines out in the world, and what scale does it go to coverage perspective is going to be a very important decision as you move forward on implementing a smarter maintenance, a predictive analytics platform for your operations as it relates to enterprise asset management and field service. So moving from things as, you know, a personal area network, which is really within your mobile phone or within the car, local area network, of course, with Ethernet or Wi-Fi capabilities. In the smarter cities, got a metropolitan area. There's mesh networks that are available over a wide area network for smart, metropolitan area networks or MANs. Then, of course, a wide area network using things like cellular and satellite. Although cellular is very, very popular, it's not always the most appropriate method for communication from call and from data needs perspective. So how do you mix and match capturing the data that you need out in the field, whether it's using potentially Bluetooth tags that are connected over to a hub on a low-powered wide area network, or whether it's tracking your rolling stock and your construction equipment that's out in the field. There's many decision points that will be made as it relates to the current IoT landscape. And how you mix and match the proper device or sensor and communication infrastructure is a very, very important decision. And the ability to mix and match both devices and sensors, as well as communication protocols and communication infrastructure that's the most appropriate for your business needs, is the biggest discussion point we have with our customers. And our customers' feedback is they like the fact that you can mix and match these types of devices and communication methods in a very agnostic way. And then kind of when we look at the hardware side of things, we'll switch gears to software. When we look at things like a Bluetooth tag, obviously, using BLE 4.0 or potentially 5.0, and what are the things you want to be able to do with it, and what's the communication capability, the distance that it can communicate from. So this could be a battery-powered magnetic asset tag that's capturing location, humidity, temperature types of data, communicating over a Bluetooth radio signal, connecting either to a hub, a Bluetooth reader hub, key gateway, or even potentially your mobile phone, which would serve as a Bluetooth reader. It could also connect to a GPS device that potentially connected to the asset or a piece of equipment. This gateway can be connected to the tags over multiple methods, whether it's low power wide area network, Wi-Fi, but it serves as the hub for data that you may be collecting over a very wide area network, such as sensors out in the that's over a 2, 3, 4 mile network or coverage, bringing that data back. And I bring this up because this is one connection back to the server where you don't need 1,000 SIM cards or cellular connections into the devices or sensors that are connected to this. You simply need one. This thereby reducing significantly your operational costs in terms of communication. And for rolling stock or assets or equipment or vehicles out in the world that are you need a very wide area network. You need a true real-time connection, such as for diagnostics or remote health monitoring, whatever it may be. You could have a telematics device that's capturing that data very effectively over a GPS, over a cellular network, and bring that data back. So how you mix it, these are kind of some types of options, and that many of our customers consider. There's also sensors that can, that are powered, connected through a MQTT protocol that comes back to the gateway that can be integrated into the system. You may have a machine that has a PLC connected to it that you want to bring that data back from the machine itself, whether it's a refrigeration unit, whether it's a cold storage container, whatever that. When you talk about what our job is to bring all this together, bring it together in a productized, easy to use, easy to get started platform, which the market has indicated is what our users want. Whether it's they want a single end-to-end platform from the device, from the communication to the middleware to the actual end user application. They want us to connect to multiple types of assets and equipment, and whether it's vehicles, rolling stock, light duty vehicles, heavy duty vehicles, construction equipment, power generators, or a mobile phone, or just a sensor out in the world. They want us to connect to that and normalize the data context around their other systems. And when I say incumbent systems, it could be connecting that data to your ERP system, to your CRM system, to your, maybe a legacy enterprise application. But that gives this data context. And the platform needs to be hardware device or communication agnostic, as well as have a very flexible API service to be able to connect other enterprise or other what we call contextual systems, such as fueling systems or fuel cards or tire systems, you name it. Other pieces of data that give your data, your real-time IoT data context, and gives you ability to make better decisions when you have that context. As a really good example, weather systems or weather data to give context to historical diagnostic or asset health data that plays a big role in your deterioration curves of the asset in terms of how long that asset should remain useful, but it gives you other contextual data in terms of deploy your assets. So if you can look back on historical data, you can also look forward with some of the data for predictive analytics, and again, tying maybe projected or predicted weather patterns into your asset deployment model. Okay, and the system needs to be very configurable by business and by each company's business drivers. So we feel the of the data that we maintain and manage needs to be very, very extensible. And also the rules engine and the workflow engine should be configurable at each customer location to model your business needs, your real-time connected asset vision into one single easy to use platform and vertical applications. Again, this is kind of a little bit of regurgitation, but how our platform, how we're driving what we call operational excellence around the digital transformation problem. So as I mentioned, it's single end-to-end platform, complete IoT and real-time asset data aggregation, combining predictive analytics into the platform, and combining that with the edge machine learning into the cloud and back into the enterprise. And ultimately, and I think this is probably the most important thing that we'd like to talk about, is how do we create actionable data and give you right now so you can stop that or potentially predict potential failures before they occur, and give that data in a very easy to use, whether it's in the web console or whether it's on your mobile device, phone or tablet, which would connect the workforce, your inspectors, your code enforcement, your maintenance staff, your operators of equipment, your drivers of vehicles, whatever that may be. And how we do that is through the vertical applications in terms of presenting this data, this vast and massive amount of data we're capturing on a minute, if not second by second basis, bringing that back in visualizing that and giving our users the tools not just to visualize that, understand the exceptions, understand the issues that are taking place now that need to be resolved, such as in this case, I drew a square around this geography, and these 3 diagnostics are available that I need to check on those. Everything else is in perfect order except these 3 events. This is where my closest technician is, that I could dispatch that technician to resolve those issues by simply providing that data to a mobile app, which we call ThingX Mobile. And this becomes the tool to push out notifications, alerts, subscriptions, and giving insight into the mobile workforce of how things are behaving, how they're being utilized, and what's the health of the assets in the field. Okay? So we visualize, analyze, and then take action. And by connecting the vehicles or connecting the asset, we create a connected asset, connected vehicle platform, as well as a connected workforce platform, whether it's inspections, work orders, jobs, tasks, or other opportunities to improve productivity and automate field service tasks, such as route planning, navigation to the asset, providing detailed information of what to do once you get to that work order or that task, and how to complete that task, and then collecting the data associated with that task for historical trend analysis and predictive analytics moving forward. And when we talk about analytics, how do we analyze all the data around smart maintenance, machine learning for better decisions and historical and trend analysis? So now we're simply looking at big data sets, analyzing the data, and pulling out the 2 to 3% of the issues or the exceptions based on rules that are based on conditions and thresholds that are user defined at each organization. So provide answers to some very difficult questions that I've never had insight into, analyze the data based on my rules and my workflows, and present that data back so I have a much better understanding, a much better insight into how those assets are being managed, maintained, and utilized out in the field. So this crunches the data in a very fast method over a long historical time period. This also allows you to connect it to any of your BI or your business intelligence tools. Publish all the data that we collect to an API or a way to connect other systems such as a Tableau or a BigQuery from Google, whatever it may be, whatever BI tool that you use, we can publish that data to give that data to you in what's called an indexed fashion or inverted index fast that you can actually crunch the data yourself with your own tools that have been developed. If we look at a use case for smart maintenance, we have a very large customer that they had a problem that many of you may have. They had escalating labor costs. Their assets, the downtime for their assets, the reliability of their assets were at a subpar metric. They had very few benchmark, very performance measures in terms of availability, preventive maintenance completion, reliability, utilization, you name it, and they're in a very reactive mode to maintenance. So, and they had a ton of paper, a ton of manual performance monitoring, Excel spreadsheets, no real-time access out in the field. So by implementing a smart maintenance and management solution that's connected via the IoT, we found we could reduce reduction in labor by about 17%. We can move forward on a predictive maintenance model. There was a 12% increase in uptime, and they really had a 180-degree digital transformation, which was really the goal. This was part of a digital transformation or digital operational transformation enterprise initiative. And then we look at kind of what were the key components. What are the key components for vision for smart maintenance, or a lot of people call it predictive maintenance, but it's really around, really smart maintenance is really just best practice in your maintenance operations combined with real-time data. So when we look at kind of what are the key components for kind of a smart maintenance program, there's really two pieces. A comprehensive asset management maintenance program combined with connected things, and this is driven by IoT connectivity. So we think it's very, very important to know exactly what you own and operate, exactly where it's located, where it's stored, what condition it's in. What's its deterioration? What's the deterioration model or deterioration curve of the asset class? How do you assign proper work to that in terms of optimizing the work order process, whether it's preventive maintenance programs, whether it's corrective maintenance, or whether it's inspection programs or safety programs? And that's really feeds into our inspection automation in terms of creating a state of good repair of all the things that you own and operate and manage to increase the useful life, increase use, help you with capital planning and replacement, help you with how do you utilize or how you right size your fleet or your equipment, how do you build condition-based monitoring around your asset scorecards, and then providing a set of asset analytics to give you the data to make proper decisions. When we connect this stuff, which many of our customers do, so if we get through the IoT, of course we can get location-based analytics, but we can also now get real-time health monitoring of all your assets. That also provides us things such as real-time odometer readings as well as real-time engine hours that helps and automate our preventive maintenance program to ensure all of our preventive maintenance programs are on track, and also then start using that data for predictive maintenance and predictive planning for your asset maintenance programs based on utilization. Well, from a predictive failures perspective, we can also then start capturing diagnostic data from the assets and start helping to identify potential on your assets by combining a series of heuristics based on diagnostic data, historical maintenance patterns, so forth, to help identify potential failures of an asset based on that data. And that also obviously provides utilization trends. You collect enough data, we can provide machine learning to learn from the data that we're capturing in real time to start doing predictive or smarter maintenance and connecting the field with that data. So when we look at the key components, that's the things we tend to look at, or we like to look at. And I look at kind of the digital transformation going from this to this. Okay, so this is before, this is after in terms of the data and the analytics that we have, giving us digital insight now versus 30 to 45 days after the issue has already occurred. Patterns, trends, and historical data gives us that information. Now, what I want to do before we jump into, what I want to do is kind of just give you a look and feel of what something like this may look like. And what I want to discuss is when we look at kind of the data that's being, this is actually looking at a real, this is a user experience, where of course, when we combine the components that we think are very important is, managing and maintaining all the things that you own, visualizing that data both geospatially through a grid as well as through graphs and charting capabilities, tying that into field service, and then providing a layer of reporting and analytical tools on top of it. So if we look at the administration and we manage something called things, this is exactly what you would think these things are. Managing things like contacts or customers, just to have some context. But you may also manage technicians. Who are my folks out in the world that operate this equipment, that inspect this equipment, or operate the vehicles? Okay, quit, look at orders, look at vehicles. So if I click on vehicles, this is simply going to be a list of all the vehicles that I own and operate. Okay, so if I look at all my production vehicles, obviously I can easily filter for that. This is giving me 100% of all the things that I own and operate in one single place, where now I can actually maintain and manage all the data. I can assign preventive maintenance plans to that. I can associate work orders to that, preventive, corrective, safety, inspection work orders I can generate ad hoc inspection forms for each asset class. And I can also do other things like assigning it to customers, assigning it to other objects in my system. So again, this is all the things are user defined, whether you manage vehicles, equipment, power generators, machines. This is all dynamically generated based on the things that we're connected to. Okay, so if I click on a single vehicle, if I click on this vehicle, start to drill down. So now we have, things that you think we should have, such as, what's the name, model, year. But if we scroll down, we'll start to see other data we're capturing. Again, this is user defined and configurable at the customer level, where we start to capture more detailed data, lab address, any diagnostic data coming off the asset, catalyst, emissions information, any piece of data that the engine is generating, we're capturing that, as well as things like active DTC codes. Any critical faults are taking place right now. Is the connection status good? What's the device power status? But this is simply an inventory and database of the things that you own and operate, the condition of those assets and equipment, the current state of that asset and equipment, and any other related things that may be associated with that. Again, this is kind of, whether it's fuel efficiency, prescription, depth fluid, is the meter connected? Am I connected to the odometer? Am I connected to the engine to drive my preventive maintenance? And then there's a series of other related lists. So what rules are associated with this particular asset? These are user-defined rules that process the data when it comes back, and we create events and associate those events with that asset. So an event is simply a time or a place where an asset or a piece of equipment create an alarm or alert that you want to be aware of. Unauthorized movement, diagnostic trouble codes, preventive plan overdue. Whatever that may be, we capture every message, but the messages are turned into events that we can easily see over the past X hours, X days, X minutes, whatever it may be. Same thing with messages. We have a device or a sensor associated with that asset, preventive maintenance plan, or can assign preventive maintenance plans, and we put permissions on any of these. So in your organization, only the users that should see the data that they should see would have access to that. You could also publish this data out to a customer, and they could see the state and status of the assets that are related to them, if that's something you choose to do. So this is very, very customizable, very, very configurable, but it could be substantially different data on your equipment or your trailers or your cargo, whatever that may be. Now we're looking at a different type of data. So if I look at, say, 203, drill down to that. Now we're looking at slightly different data with inspections. So this is my weekly inspection. Any messages that have come off this, any orders associated with that, and what my preventive maintenance plan is. So now, if we're capturing information from these assets, such as odometer readings, those odometer readings or engine hours will drive the preventive maintenance program. And I'll discuss that when we discuss visualization component. Obviously, any geofences, anything you want to geofence and capture utilization or statistical data from can be developed easily, then start to see information such as, click on it here. If I wanted to see anything that's happening in geofence from utilization diagnostic perspective, we can easily draw geofences around those and then add rules to that to give us the proper information in terms of diagnostics, utilization, geospatial information, and historical trends. Obviously, building the rules-based engine, whether it's DTs, whether it's asset health monitoring, speeding, idling, whatever that may be, device disconnected, these are tools that our customers can build very, very easily to set the conditions and the thresholds. Now, when we talk about connectors, our connectors connect back into other systems, whether you're a SAP user, a Salesforce user, another type of user, as well as any telematic related information, the OEM manufacturers, And then visualization tools, whether it's connecting to weather systems, current as well as historical and future, forecast, plan your asset utilization in the future, Google Maps, or your geographic information system if you have data to overlay on top of that. When we talk about visual, capturing all this data, we're bringing that data back, but giving you an idea of the types of data that we're capturing. So now we can see our technicians. We can see, show me where all my apps are. If we're connecting, say, to a mobile device or a mobile app, we can now easily see where all of our mobile workforce is located. But we can also see things like, where's all our customers located? So now we're looking at customer-related data. In this case, let's look at Stonebridge oil fields. We can see the customer, and see our other customers here. But we start looking at the other data that we, to give you an idea of the types of data, these are user-defined layers that I can easily create a new layer on. But give me an idea, here's some kind of real-world information. These are exceptions that this particular customer is. Show me anybody at this particular job site or any asset at this job site. Give me my meter exceptions, where meters are not being calculated, or emission summary, any of my failed inspections, fuel charts, any critical faults that are going on right now, anything that's underutilized, any piece of equipment that's underutilized, we can easily see that and visualize that both in the web console as well as the our mobile app. So now I have my layers here. So now we can see we have one asset that's underutilized based on the rules for their utilization rule. To give you an idea, any active DTC codes that are going on now, any fault codes that are going on now. What messages did I receive last hour from the South region? So these are very easy to use, very flexible layers to be able to visualize things very, very quickly. Give me an idea of if I go to click on live tracking. So now we're going to start assets out in the world. That just happens to be within a geofence. If there's any assets within this geofence, we now have a series of layers that we can now easily see, whether inspectors, whether live tracking. If I want to turn on clustering, I can easily turn clustering on. Now we're seeing assets in different fashion. If I want to see those heat mapped or any issues on the heat map, I can easily see that as well. If you want to see historical data, you could also turn on historical data. So anything with historical related information, we could easily turn on, historical data. Say that. Turn that. I'll be doing something wrong, but we could heat map that pretty quickly. Now we're showing in the grid as well. So if we look at kind of grid data, now we're just providing the data that you may want to have access to. Now we're looking at preventive maintenance statuses, who's on schedule, what's past due. But notice this odometer value is driving every bit of this preventive maintenance schedule. Now, when I say preventive maintenance schedule, again, if you look at the top of it, it's a ton of information about the engine, about the asset that we can easily view, and we can combine that with historical work order data. So if I were to give you an idea of in this particular, if we have anything like PM, predicted preventive maintenance schedule, preventive maintenance issues that appear to be taking place now that I need to resolve, we can identify those. We can easily dispatch. In this case, maybe a field service person says, hey, this is where all my orders are. Here's the things that to do today. Or look at all my facilities. Now we're looking at all the things that are happening now that we need to resolve. Okay, so simply looking at work that needs to be done that could be dispatched to a mobile technician, to a mobile field worker to resolve that issue very quickly and very effectively. So now we're starting to look at orders. So we're generating actions to resolve potential issues out in the field and world. So this is an order to address a DTC code that we need to dispatch and resolve now. If you want to look at it in a different way, we look at it in this way here. So this is simply where my work orders are they completed, what's the status? And by the way, all this data is available on a mobile phone, on a smartphone or a tablet to your mobile workforce, so they can pull out the same type of data and give me an idea. Also do things like subscribe to any notifications that they care to subscribe to. Simply, these are the things that I want to know about if a DTC code is going on right now. Okay, so when you look at manage and maintain all your inventory of assets, condition, utilization, status, location, preventive maintenance plans, any work orders associated with your assets, visualize that data. Okay, we can start to see a little bit more information. In this case, we can see that. Automate your field service programs, and then access reports. So, and I want to talk about reports in a different fashion. There's standard reports, there's ad hoc report generation, there's dashboard capabilities, but there's really different layers and different levels of types of data that you may be interested in. Let me go back to here just for time's sake. This is just a visualization of utilization. So this is a different way to look at the data. These are flat lines because these assets are not, these are the assets that have not been utilized a date period, a date span. So these are, any of my real-time vehicles, where they're located. Here's my diagnostic trends, show me any perspective, show me my utilization trends. And then here's all equipment. So it gives us a very flexible way to view our data. But it also has to mine that data. So as an example, this would be a basic user saying, hey, show me what my equipment report is. Show me my inspection, all the inspections that got completed last. Show me any asset that has an active fault code going on right now. However you want to access that data, you can sort, group, filter, and build your own reports in a very flexible fashion. So this is really designed for users, end users, not just admin staff, but actually end users. The application can access the data they need to get insight into their operational role. Now, as we start to visualize data a little bit differently, we want to present this in a dashboard component. So now show me the status and state of my preventive maintenance work orders, what's not performed, what assets do not have a maintenance schedule associated with them, so I can resolve those now versus those causing issues down the line. How do I make sure I stay 100% on my preventive maintenance schedule? And if we can do that, we can extend the useful life of all your assets. We can reduce your downtime. We can improve uptime. We can improve performance of those assets. And we can also help you make decisions around capital planning and replacement. So as we move and start looking at now we're looking at capital planning and replacement, of taking all this data that we've captured and giving it to us in a format that we can easily understand and easily help us make decisions on based on your rules and your workflows and your capital planning processes. Next, now we're looking at a little bit more detailed information of, now we're looking at a cost analysis by, what's my average maintenance cost per mile. This feeds into more, which I'll discuss in a second. Show me my scorecard by department. Show me my maintenance cost by department. What's my financial contribution in terms of budgeting and cost allocation. Who's idling? Who's costing me money by idling too much? This is just simple insight into what's going on. It's delivered in near real time because it's connected to smart assets, smart vehicles, smart sensors, multiple communication methods. What's being utilized, what's not being utilized. So you can easily see things such as that nature of who's the most, what's the duration of who's utilizing the equipment the most. So this is just tactical operational data that really allows our customers to make better decisions now. It gives them digital insight into operations and helps them ultimately make better decisions as to how your company is maintaining your assets, utilizing your assets, and deploying your assets and generating productivity efficiencies from those assets. Okay, Now, again, just a different way to look at it. This is very tactical stuff, but idling, trends, harsh driving, or unsafe operations of a piece of equipment or vehicle is very, very tactical information, but very, very important information. If we kind of go back, very simple, create a layer, chart it, graph anything you want that's numeric or related. Give me a list of something, group it, filter it, chart it, graph it very easily. Put geospatial queries. Now let's look at a little more strategic. Is let's make sure we stay on task for our preventive maintenance programs. Now help me understand how I should replace my assets based on all the utilization, all the work order information, all the contextual data we're capturing about the assets, all the duration model we have on these assets. Help me understand how I should replace these and when should I replace these. And if we can help you extend the useful life of your assets by 10, 15, 20%, that's a significant return on investment for these types of systems. And then now show me where I'm spending my money. It's being allocated across different departments, how I'm utilizing those assets, any trends or any tactical things in terms of cost maintenance and operations dashboard. Now let's take a look at historical time series data. Let's take a look at different events and different and different things that are taking place out in the world. And now let's pull out the exceptions that you're interested in and put a geospatial on it. There's a graph component, there's a utilization component on it, a statistical component to it, to analyze over a long time series to pull out the exceptions and give you insight into your patterns and trends as it relates to utilization, diagnostics, and performance. If we get to the most complex, is how do you start feeding to a more advanced predictive failure model in terms of taking statistics, your KPIs, and your asset benchmarks, understanding the equipment or the vehicles or the assets that you have, any work order history, preventive maintenance, corrective maintenance, the cost and the locations, and then feeding that information into the data that we're capturing to create models for failures of components, whether it's a failure probability, a weighted probability failure for engines, all your other major components as it relates to an asset, whether it's chassis, hydraulics, transmissions, you understand, or whatever that may be, and give you really significant insight for things that are expected or predicted to fail over the course of its useful life, and give you that data now to help you make decisions around your maintenance programs and actually create a smarter maintenance system and a smarter inspection program and a smarter utilization program for the assets, equipment, and vehicles you're operating. So if we look at kind of a recap of this webinar, the trends reporting certainly pointing into smart maintenance is the future. All of our customers have initiatives to help become smarter. They have other initiatives as well that wrap into this in terms of not just having smart maintenance, but a smarter mobile field service program, as well as a smarter asset management, maintenance, and work order program. But how do we create smarter maintenance through combining these technologies and really wrapping these and integrating these through the flexible and configurable way? When you talk about the IoT or the industrial IoT, really creating automation and streamlining work processes, your assets a little bit more efficient out in the field, moving from a manual process to a fully digital process for real-time data capture, real-time inspections, real-time work order planning and navigation. And obviously, one of the recaps I like, it's all about digital transformation, and that's driving many of our customers' success is their focus on digital transformation. And how do you get there? And a very important key piece of this discussion is how do you scale that for success? So, how can you capture petabytes, massive amounts of data on a daily basis, put workflow and rules on top of that data to answer very, very tough questions. And it is really, really important. So scalability is an extremely important piece to this puzzle. And really, the question we often ask is if you know the state, status, and the health of everything you own and operate out in the world, and you can put a layer of logic and workflow on top of that, what questions would you answer within your organization? And those would be very, very big questions and very, very difficult questions. But these types of solutions, this type of platform, combined with kind of the approach, will really allow you and allows our customers to really make very, very, answer those very, very difficult questions. I want to thank everyone for attending. We have about 10 minutes left. Dan, I'll leave that open for any questions or clarifications, but Dan, I'm going to turn it back over to you.
Yeah, sounds good. Well, Tim, we do have a bunch of questions. We're not going to be able to get through all of them today, so certainly we'll follow up with everyone on the webinar today on an individual basis to answer any specific questions or needs that you have. I pulled out a few that I think are relevant to the discussion today that I want to definitely have Tim address on the call this afternoon. The first of those questions is, Tim, having worked with the companies that you've worked with deploying industrial IoT solutions, what are some quick wins and some advice that you could give for companies that are just starting to get into an IoT initiative? What are some things that you should be thinking about, and what are some quick wins that they could achieve to show success across the organization?
Okay, very good question. So there's kind of probably 4 very quick wins that are very quick, very easy, very straightforward. A comprehensive asset list inventory of everything you own and operate in one single easy-to-use application that's connected to your other enterprise applications to give that data context. So knowing exactly what you own, what you operate, what you inspect, what you maintain, and where those things are in relation where they should be is something that's very, very important. The first one. If we can get that done and connect your assets, your equipment, your vehicles via the IoT, the next big piece is how do we automate and drive your preventive maintenance program to make sure that it's without question 100% always on track and maintaining a state of good repair within your organization are quick wins those are 2 really quick wins that kind of are out of the box. The next piece is, it's a little more complex, but exactly how those assets or that equipment, those vehicles are performing. What diagnostic data is being collected, what utilization data do you need to help you make better decisions, how you process that data, so you get that data within a minute or so from the time the failure starts, is also a very, very quick win. That can solve massive issues operationally in terms of failures or issues or incidents within an organization that really depends on those assets and their equipment being in top order. And then how do you, the next piece is how do you distribute that to everybody in the organization that needs that data to make better decisions? And obviously, smartphone apps and things of that nature are always really good concepts around, push notifications, subscribing to alerts, subscribing to messages that I might need. But those 4 components, creating kind of the asset inventory, driving your preventive and predictive maintenance programs, understanding your health of the assets out in the world in real time, and then being able to connect your workforce to resolving issues that's being calculated or being captured now. So it's not just visualization, it's not just analytics, it's workflows, rule generate actions to help solve the problem is a very, very important concept. Those are 4 or so very, very quick wins that organizations can quickly move forward on.
Tim, last question for you today. How do you get started with an initiative like this? What's kind of the process? What are some best practices that you see from organizations who have been successful in adopting this type of technology? Where do you start?
Well, I think it starts with the organization in terms of understanding kind of what's your pain points, challenges, what are your use cases for something like this, and what's the priorities within your organization for how do you phase that in based on your priorities. It may be something as simple as just knowing where everything is all the time with a GPS unit in your rolling stock and Bluetooth asset tags on your light or small equipment. That in itself at least gives you know exactly where things are in relation to where they should be. And there's a lot of side benefits that, of course, but kind of understanding what your business, what your challenges are, what your top priorities from a business perspective are as it relates to connected devices, connected things out in the world, or the places that in terms of getting better things organizations need to really determine internally through stakeholders, and getting stakeholders involved in your enterprise, whether it's getting your IT staff and your operational staff together to understand what the technical requirements might be, but really more importantly, what are the operational use cases that need to be solved that are causing a lot of pain, and then prioritizing those from the highest to the lowest, and then developing a plan to how to address the high priorities, and then how do you phase in or scale in the medium to low priorities as you move through the life cycle of these projects. And having that plan and that approach is a very important thing. And of course, I have to say this, I mean, we work very closely with our customers and the folks that we're dealing with out in the world to assist with that in terms of what is the strategy, what priorities can we address very, very quickly, which protocols that would be the most appropriate, what's the device, sensor, or thing that's most appropriate to implement on the stuff that own and operate. So we certainly can help with that once the requirements and the business priorities are identified out from a plan perspective and from a phased scale perspective.
Great, thank you very much. And for everyone on the call, again, appreciate your attendance today, and thank you so much for taking the time out of your day to join us. Hopefully this was informative and educational. Again, we'll be announcing the winner of the $100 Amazon gift card over the next day, so stay tuned for that. Best of luck to you all. And again, thanks for your attendance. We appreciate your time, and we'll be following up with everyone who joined us today on an individual basis. If there are things that we can assist with moving forward, even if that's opening a high-level dialogue around some high-level initiatives that you have going on within your business, we'd love to have that conversation. Love to work with you individually. So certainly don't hesitate to ask any additional questions as they come up. And we'll also be distributing a copy of this webinar out to the group after the meeting today. So thanks again, and have a great afternoon and a great weekend.